we're going to take a look at how changing dimensions affect surface area and volume. If we have a scale factor of k, then the surface area would be k squared times the original surface area, because the way that you label area would be the unit of measurement squared, like inches squared, feet squared, whereas volume would be cubed, feet cubed, inches cubed. Now, if the dimensions of a figure are doubled, that means times 2, so 2, but because we're dealing with surface area, it would be 2 squared, which means that the new figure would be 4 times larger than the original figure. And then number 6, it says the volume of the figure is 110.5 cubic feet. If the dimensions were doubled, what would be the new volume? Well, in this case, we're dealing with volume, so that would be k cubed. Still doubled, that means 2, but it would be 2 cubed, which would get us 8. Now I multiply 8 by the original volume of 110.5, and our new volume would be 884 feet cubed. In our next example, we have two different shapes. We have cone A similar to cone B. If cone A has a surface area of 1,422, B has a surface area of 158, how many times larger is cone A than cone B? Well, we first would want to divide the two volumes, or the two surface areas, to figure out what that scale factor is. So we would have 1,422 divided by 158, and then we would get 9. So 9 would represent your scale factor K that was being squared. So to undo that, we have to take the square root on both sides. So the square root of 9 is 3, so it would be 3 times larger. In our last example in this section, we have the volume of the figure is 972 meters cubed. If the dimensions are multiplied by 2/3, what would be the volume of the new figure? Well, again, this is going to be our scale factor, so we would have 2/3, and because we're dealing with the volume, we would then cube it. So when we cube that fraction, we would have 8/27. When you cube a fraction, you cube both the numerator and the denominator. Then we multiply that 8/27 by the original volume of 972. When you do that, you get a volume of 288 meters cubed. Now, use logic to see if your answers are reasonable. So for example, if it's 2/3, that means it's got to be smaller than the original volume, so it's got to be less than 972. In the next section, we're going to take a look at, well, what happens if you only change one dimension? In the first half, it was talking about what do you do when you change the entire volume or the entire surface area. So in our case, we need to understand that if you change one dimension, the figures are not similar. Therefore, we need another strategy. In a situation, we choose the scale factor, and we calculate both the new and the old surface area, and then we compare our answers. In this example, we're trying to figure out how many times larger is the volume if the height is doubled. So in this example, we're saying what happens if you change the height. The volume of a cylinder is pi r squared h. And notice that the part being squared is the radius. So that is going to be affecting the volume at a faster rate. However, the height is just one dimension. So we can pretend that the height is 2. So then if I plug in pi r squared times 2, and let's say the radius is 1, pi times 1 squared times, let's say, the height of 2. Well, when I do that, it would be 2 times pi. So that means when you double the height, it's really 2 times larger than the original volume. It's going to be 2 times larger. The other thing that you want to think about is when you are changing the height only, then when you are changing the height, it's going to be equal to scale factor of what you are changing it to. Let's compare this to what happens if you change the radius. We'll use our same values. We'll use 2 for the radius and 1 for the height. So we would have pi, let's say we double the radius, so that'd be 2 squared, and we'll say the height is now 1. So we're switching which one's being doubled. and I'll label this side. When you simplify that, you would have 4 times pi. So when you are doubling the radius or a side length, that means it's going to be whatever that side length was raised to that power. So in our case, if you square the radius, you can see that it's 4. Well, again, the other way of thinking about that would be whatever you are doing is doubling it squared, and that's where the 4 comes from. So if you change the radius, it would be 4 times larger, versus if you change the height, it'd just be 2 times larger. Number 12, how many times smaller is the surface area of a cube if the side length is multiplied by 1/4? So if we do surface area of a cube, again, that's just going to be one side length times the number of side lengths of a cube would be 6. So it would be 6 times a side length squared. Now, if our side length changes, that means it's 6 times 1/4 quantity squared. And when you square a fraction, remember that you're squaring both the numerator and denominator. So it would be 1/4 squared, which is 16. So it would be 16 times smaller than the original surface area.